Hi everyone, welcome to Math Moment with Mr. Dustin. I'm Mr. Dustin. So today we are going to be discussing different types of angles. This is a concept that is normally learned in a high school geometry course. However, it is very useful for the SAT, so it could be a useful preview for anyone looking to perhaps get a look at what could be on the SAT, or it is a good review for anyone who is looking to review for the SAT. At the end of this video, there is also a formative assessment. The link is in the description. And this time, if you do take the formative assessment, there will be a code at the end, and this will lead to like the code that you can enter into Beanstack for the virtual visitor badge. So in order to get this code, you do have to take the quiz. So I encourage you to do that. Enjoy the video. Okay, so today we're going to be looking at various types of angles. Now these are generally very helpful for SAT questions and for proving that one angle is equal to another or maybe is not equal to another. These are questions that you'll be asked in a high school geometry class, most likely, because we're very concerned with angles in that kind of class. So let's take a look at this diagram here. This is something you will see very frequently when talking about these types of things, and it's something that could pop up on the SAT, perhaps, so kind of important. Basically, you have two parallel lines, L and M, and they are cut by this line T, which is known as a transversal. And so because of that, there are 8 different angles that are formed between the transversal and lines L and M, 4 for each line. So let's take a look at what alternate exterior angles are. Now, what do they mean by exterior? Well, exterior basically means this side of the line L and this side of the line M. So above L and below M. And so alternate indicates that we are looking at angles that are on opposite sides of the transversal, meaning one that's above L and one that's below M, but they have to be on opposite sides of the line T. So one example of this is the angle 1 and the angle 5. These are alternate exterior angles. And now there's also one more example on this one. It's 4 and 6. And they are, you can see 4 is above L and to the right, or sorry, the left of the transversal, and 6 is below and right of the transversal. So that means they are alternate exterior angles. Now, why is this important? What's the significance behind an alternate exterior angle? Well, basically, an alternate exterior angle indicates that they are the same measure. For example, if angle 1 was 45 degrees, angle 5 would also have to be 45 degrees. Same if we said angle 4 was, let's see, 180 minus 45 was 135 degrees. And then we'd be able to say that angle 6 is 135 degrees. So that's just the relationship between the alternate exterior angles, and that's why it's important. And you can say, oh, well, why is angle 1 equal to angle 5? Well, now you can say it's because they're alternate exterior angles, and that would be enough to prove your statement. And so let's look at the next example here, alternate interior angles. Now, interior indicates that they are between the two parallel lines, so below L and above M. And we know alternate from the previous term was on opposite sides of the transversal. So what would be our alternate interior angles? Well, 3 and 7 would be an example of alternate interior angles. Another example is 8 and 2. So I'm going to write these down real quick. 3 and 7, as well as 2 and 8. Now, what does this mean? What's the relationship between alternate interior angles? Well, surprisingly, it's exactly the same as the alternate exterior angles. You can see that angles 3 and 7 are the same measure, like the same amount, and angles 8 and 2 are the same amount. So like if I said angle 3 is 135 degrees, well then angle 7 is definitely 135 degrees because of alternate interior angles. And again, that's all you need to say to prove that there's that relationship between them, because it is a proven thing in mathematics. And so most people will definitely accept like the reasoning alternate interior angles as your explanation for why those angles are the same. So let's take a look at corresponding angles. Now, this is a little different than what we've talked about so far. There are actually 4 pairs of corresponding angles in this figure here. And so let's take a look at what they are. Basically, it's the same angle. And all right, so angle 1 here, right? You can see where it is in respect to L and the transversal T. Well, what about M and the transversal T? You could say 2 matches up with angle 1, hence they correspond. And so it's the same measure, and they're in the same place on the line there. So we could say, oh yeah, 1 and 2. What else do we have? Let's look at 3. Which one corresponds to 3? Well, that would be 6, right? It's below the parallel line, but to the right of the transversal. So 3 and 6. And then what else do we have? We have angle 4. Well, let's see which one corresponds to angle 4. That would be angle 7, right? Above the line that's parallel and to the left of the transversal. So we could say 4 and 7. And then there's one more pair. Let's see which one that is. Angle 8 corresponds to angle 5, below the line that we think is parallel and to the left of the transversal. 8 and 5. And similarly to the other terms we've learned so far, these are the same length. Corresponding angles will have the same length, or the same degree measure. That's what I mean. Yeah, so those are corresponding angles. And now we're going to go into a break. So enjoy the break, and we'll talk more about different types of angles after that.
This is an egg without its shell. It was soaking in vinegar for 2 days, and now the shell is disintegrated, and all that's left is the membrane. So we're going to be cutting it open and seeing what the yolk is like.
It's not as bad as I thought.
Yeah, me neither. I think it would have been worse a couple days ago. Oh, there's like 2.
Interesting.
Yeah.
The membrane isn't like, I don't know, the membrane is really solid still, you know?
Yeah. It's kind of like skin, which makes sense.
Yeah.
Yeah. That's it.
All right, welcome back. I hope you enjoyed the break. Let's take a look at some more types of angles here. So this is the vertical angles. So like the corresponding angles, there are 4 different pairs of vertical angles on this figure here. So let's take a look at angle 1 right here. Basically, a vertical angle is going to be angle 8. So you see how there are the 2 lines that intersect? Well, it's like on the opposite lines. They're not adjacent to each other. That's the main thing. They are not next to each other. And so that's what defines a vertical angle. You cannot have a vertical angle between like 1 and 5. That would be what we know as the alternate exterior angle. So it's between 1 and 8. So I'll write that down here. That is one of our pairs, 1 and 8. Now, there are 3 more pairs in here. So let's try and identify them before we figure out what they do. 3 and 4, I would say. And then there should be 2 more, but they're probably on the bottom now. 2 and 5. And then 6 and 7. These are vertical angles. Now, what do they do? Well, again, like everything else we've already gone through, they are going to be the same. They're congruent. They have the same measure. So angle 1, if you say that's 45 degrees, then angle 8 is definitely 45 degrees. Angle 3, if it's 135 degrees, well then 4 is definitely 135 degrees. So that's kind of the beauty of vertical angles. And again, just saying, oh yeah, these are vertical angles, that's why they're the same, is enough to prove that they are, because it's a proven part of mathematics. So let's take a look at some other angles now. Same side exterior angles. So this time, we're not looking at alternate. We know what exterior means. It's going to be either above L or below M. But we're looking at same side. So for angle 1 here, the same side exterior angle is going to be angle 6. So that's one pair. 1 and 6. And then the other pair is going to be 4 and 5. Like so. So you may be saying, oh, what's so special about same side exterior angles? Well, notice what's different from before is that these are not the same length. So what can we do about this? Well, let's take a look at 1 and 3. Now, would you agree that these are supplementary angles? The answer is yes, you should agree. They will add up to 180 degrees because the angle, like if I were to draw a line here, here's the angle 1, and here's angle 3. Roughly, this will make a half circle. Now, excuse the bad drawing, but this will make a half circle, which is 180 degrees. The same will go for 1 and 6, because notice 3 and 6 are corresponding angles. So they're the same, and that's kind of a little bit how this is proven. So you could say that 1 and 6 are what are known as supplementary angles, and that means their measurements add up to 180 degrees. So if I were to say 1 is equal to 45 degrees, well then 6 is going to be equal to 135 degrees, because 45 plus 135 is 180. And so that is why, or that is what is so special about same side exterior angles. It's basically identifying a pair of supplementary angles. And so keeping that in mind, let's take a look at another example. Same side interior angles. Now, remember, interior means below the line L and above the line M. So in this middle section here, the interior, if you will, and we're going to be looking at same side interior angles. So 3 would be a same side interior angle with 2. And it's kind of the same principle as the 1 and 6 thing, just that they're interior. So 3 and 2, as well as 8 and 7. 3 and, come on, 3 and 2, 8 and 7. These are our same side interior angles. Now, what's so special about these? Well, just like we discussed last time, you have your angle 3 and your angle 1, oops, and they create a half circle. That's a better half circle, I think, than before. And so we're going to apply that same kind of logic because 1 and 2, as we know, are corresponding angles. And what do we know about corresponding angles? They're the same length, or like the same measurement. So if you take 3 and add it to 2, we know that those are supplementary angles, which it will add to 180 degrees. It's the same idea as the same side exterior angles. So add to 180 degrees. Now, just to review everything so that we have a clear understanding of what they do, I'm going to go all the way back. So what do the alternate exterior angles do? Well, they are the same measure. For example, 1 equals 45, and so does 5, right? Same with the alternate interior angles. They are measured. And the same can be applied to the corresponding angles. And this one you're going to find is very helpful. The corresponding angles are great. They're one of my favorite angles actually, because they're so easy to work with, and they're like useful, and more so than the other ones, I think, in proving things. There we go. Let's see, it's not break time again. Sorry about that. Vertical angles. Let's see. They oops, measure. And then finally, same side exterior angles and to 180 degrees. And so these types of things will be very important when proving what the measure of a certain angle is, or in showing your work, you can say, oh yeah, same side interior angles. I know what the measurement is of the missing angle. And in a future video, I'm going to go over more of applying these concepts and also some more terms that may have been missed in this video. So stay tuned for that. Thank you for watching this video, and be sure to take the formative assessment, and the link is in the description. And this time you can actually earn points for your virtual visitor badges for the library's summer reading program. So I encourage you to take the quiz, because that's the only way you can get the codes that you need to earn those points. So yeah, thank you for watching this video, and I hope you enjoy the rest of your day.